Hello, everybody. I'm Lina, and today I will talk to you about what I learned monitoring the last 30 production cases I was programming and putting into production. Okay, so a really quick background on me. Who am I? I'm a freelance machine learning engineer. I'm also the lead engineer at a big German online bank, DKB, and I used to work at a huge e-commerce stores. Maybe those from Europe know it. It's like makes more than a few billions of revenue. It's called Zalando. And these 13 models that I speak of, they're not like all types of machine learning. They were mostly in recommender systems, personalization, some NLP models in customer service, and finance-related models. And we are speaking about large-scale production systems. Okay, so basically when you look into the machine learning tooling space, it can be a little bit overwhelming and there's a lot of development in the area. So what I want to do for you today is give you my very pragmatic monitoring blueprint that I've developed over the years that I find works reasonably well, and let me know what you think. So what I will cover is first the basic software monitoring requirements that everybody has for a backend service. For some of you, which might be backend people, this might be a repetition. If you're a data scientist, this might be new for you. And then I will tell you how to add machine learning monitoring on top of that and how you can achieve that with relatively simple tooling. Okay, so let's start with the basic monitoring recap for backend engineering. So it's important for you guys to know that have not yet operated anything in production that incidents, so meaning a degrading of the customer experience, is really normal. Unfortunately, there are always bugs, there can be human errors, so it's not possible to avoid problems. Our goal instead is to detect them fast and act based on how severe they are. So even really big players like Amazon or Google experience outages, and they have really top-notch engineering teams. So if they're able to experience an outage or a degradation of a service, it will happen to you too. That's why you need the monitoring. So what do we use for backend monitoring? Typically, SRE, so Site Reliability Engineering from Google, came up with these 4 metrics, which are super useful for any backend service, which is latency, so the time it takes you to serve a request. Then traffic, how many requests you get. Errors, these are requests that fail. And saturation, so the load on your network or on your service. This means we focus on symptoms. That means end user pain, not causes. So our goal is to really understand if the user starts to experience some difficulties, some stuff is not reachable, or maybe it's really slow. And that's what I recommend, and basically what Google recommends for you to use for all your backend services. How does that look like? So what you do is you somehow collect these metrics. This can be with your cloud provider, it can be with your own metrics. So find out whatever you're running, how to collect these, and then you push them somewhere and have a dashboard. This is a Grafana dashboard. You can use whatever monitoring solution you have already in place or select one. And then you graph this over time. For example, here you see the speed in which you return a request. This is the latency on the top left, and you see how many requests you have. Oh, you're still seeing the first slide. Maybe that's your connection. Is everybody else seeing the slides that come after this? Now you should see a dashboard slide. Okay. Maybe, okay, cool. So maybe something with your internet connection. Awesome. Okay, so I will move on. So what you see here is this Grafana slide. So that's what you want to first graph and collect, and then you want to alert on it. And how do you alert on it? Alerting means that you get a notification when something starts to become too low or too high. And this is what Amazon CloudWatch provides. So there are different technical providers that can allow you to say, this is the metric. You send this metric there and say, okay, now we have this many requests per second. And if it goes below or above a certain level, I want you to notify me, for example, per email or to your phone. And here's the CloudWatch example how to do this. So is that enough if you have a machine learning stack? So what you can see here is a extract from a Google paper called Machine Learning Test Score, a good paper if you want to read it. And it shows you that machine learning applications have a higher complexity than normal software systems, because in addition to the normal tests that you have to do, unit tests, integration tests, system monitoring, you also have the data that comes in. You have the model itself, the infrastructure that you use to run the model, and that introduces even more things that you need to monitor. Here are some examples from my personal experience where the 4 golden signals that I introduced to you a few slides ago did not catch a problem, but we did have a big problem. So for example, the input data can change. We had a fraud model where there was a unit change, and instead of sending us seconds, someone who calls the model changed from seconds to milliseconds. That is still an integer value, but suddenly the model gives very weird responses. And in the training data, this was actually still in the other unit, and this caused huge problems, and it takes a while to detect. Another time, we had an external service that we called an article service, and we migrated from one service to another external service. And this new service didn't have all fields fully filled, so we got less fields back to filter on. So this is also a problem. Other examples are bugs in your own code. So we had a bug where we did get the last 10 orders versus the last 10 bought articles. So something stupid. It will not cause an exception, but it will give you very different results to what you expect actually to go into the model, namely the 10 last orders. Other examples were that we did not pin our TensorFlow version, and we got a version nightly. And yet another example was that the client, maybe if you're in a bigger company, changes the way that the product works without telling you. It is rolled out to a new country, or in our case, it was now used by users which were not logged in, which is a completely new distribution. So what you can see here is that there's a bunch of things that can go wrong, and none of these things create an error or slowness or saturation. They are quite silent. And some of them, for example, a big post-processing rule that is very aggressive can cause huge monetary losses for your company, and even bigger losses than what you can achieve when you work on 2 months for a nice model improvements of 2-3%. And so this is really worth detecting if you can. So now that I've motivated you that you really need these additional machine learning monitoring, let's talk about how this can be achieved practically. I have an example. One of my latest cases is process cost optimization for private loans. So what is happening, just so we can talk about a live example, is that a customer goes to a comparison website for private loans, and the comparison website calls, let's say, 20 banks and says, what interest rate would you give this customer? And we are calling the credit report agency, and they charge us for each request. So ideally, we would like not to call this costly external service if we already know that this customer will probably not get the loan with a really high certainty. So what we have as inputs, we have a bunch of data fields about the application and the customer, and we would like to predict if the loan will be accepted or rejected on our end. Okay, so now that we have our correct example, like concrete example, let's talk about how to prioritize monitoring, machine learning monitoring for this use case. Generally, my recommendation is that we prioritize backwards from the output. So very similar to site reliability engineering-based monitoring, we want to focus on the impact on the end user. So this means if on the left side there's the data, it calculates feature, then there's a model prediction, then there might be some post-process filtering, and then there evaluation metrics, after we know the ground truth, that you should start at the very end towards the user. So what does this mean? Sometimes I get a data scientist like super confused. How can I monitor my evaluation metrics in production? Sometimes you can do that. So it depends if you know ground truth, so target values close in time. So let's say I make this loan prediction and I say this user is probably not going to get the loan. And if there's a really high probability that he won't get the loan, I will reject this user. Do I know then what would have been the outcome? No, unless I make a test set where I'm letting people through. So there's a bunch of cases. Some people are only seeing the first slide. I'm sorry about this. Let me quickly check maybe. Let me see if I can solve that for you. Definitely try refreshing. And if this doesn't work, try this repository and try to go along on your own. So there's the slides in there. Okay, try refreshing. Someone says refreshing. If not, try this GitHub link and follow along on your own. Okay, thank you. Okay, wonderful. Okay, so basically, do you know the correct target, the final outcome close in time, so you can compare the model prediction to what actually happens? So sometimes if you reject someone, for example, high fraud probability or high probability that they won't get the loan, we don't actually know if we made an error. In a second type of ground truth situation is you get a delayed result. So if you predict package delivery time and the package finally arrives at your door 2-3 days later, you have a delay between your prediction and what was the final outcome. So this is a bit difficult for real-time monitoring, but at least you get the ground truth eventually. And then you have the case where there's a filter bubble effect, where the algorithm decides what to show, and you can never evaluate unseen options that might have been better, for example, in cases of recommender systems. So what does that mean? It means in cases where you can do it, I strongly recommend that you monitor the evaluation metrics in production. So what you do for this is you store the prediction and you collect the eventual target, and you calculate the metrics that you also use during evaluation. For example, you use a batch job, or you create an endpoint, an API endpoint to receive a feedback call. And then you add these metrics to a dashboard and you create an alert that you are notified when it goes below or above a certain level. In my concrete case with the loan prediction, if we reject, the correct target is unknown. So what we do is we take a small sample of the traffic and say for these users, we actually don't apply the model. This is also often done in fraud. And we let always these people through and see, and for these people, so then we get ground truth data and we can compare the prediction and the actual and monitor on this metric, on the comparison. So here you see a dashboard where I calculate these evaluation metrics in production. In this case, it's recall and precision. And I have an alert that I set if the, for example, precision goes below a certain threshold, that I get an email and I can have a look if I need to do something. Another priority I recommend to you is to talk to your stakeholders about their worries, what could happen when you put the machine learning model live. As machine learning engineers and data scientists, we usually just think of the upside, but stakeholders sometimes are also quite worried about adverse effects of a machine learning model, and they really need to trust it. So it's well worth taking the time to ask them about their fears and putting these into models. So you would detect these scenarios and you don't have the situation where like your stakeholder calls you and is like, did you notice it's doing this and that? And you never noticed. So that's what you want to avoid. And so, for example, I asked them, with the loan prediction model, what are your fears when we put this live? One of the fears was obviously that they were worried that we would reject people which would have passed the credit application process. So we have this live test sample and we can alert if our precision is below 95%. They were also worried that we would make the whole application process slow. It's also a very important insight that they were worried about this. And then we can discuss latency requirements. So I always recommend to talk to them about these downsides they have in their head, and they're maybe not necessarily telling you, but they're quite worried about. So then we're at the second priority. So we're moving backwards from the user output. So obviously, if the evaluation metrics change, the user is directly impacted. There might be some cases, though, where you don't have the ground truth. So the next best thing would be to monitor the service output, so the service response, after any post-processing rules, any business rules. So how does that work? So this is pretty good. Many people working in ML and data science are always thinking about metrics as something that measures the quality of a model. So it's an important mindset shift to understand that in monitoring, we're actually not thinking about measuring quality, but having metrics that detect a problem. So they can be quite bad at monitoring your actually absolute quality. It's just important that they go down when there is a problem. And so that's very nice because these detection metrics are easier to implement. So one detection metric could be your output distribution. Let's say you have a classification and you predict a certain category, and the category has a score. So if you normally have 95 or 90 quantile of such score, which is 0.9, and suddenly you have a score which is 0.4, so the model is a lot less certain what the best category for an input is. Something significantly changed, and it's very likely that it also got worse for the user. So this is a great proxy to monitor for a quality problem. If you monitor a histogram, for example, of your output, you can apply different detection mechanisms on this. You can monitor the median, quantiles, share of empty or insufficient outputs, and you can also do statistical tests, Kolmogorov-Smirnov test, D1 distance that Google is using, or a population stability index. In my experience, you're already getting really far with just these rule-based distances. And an advantage is also that you have this output relatively fast. So if you think of the case where you predict package delivery time, it will take a few days till you understand if you made really bad predictions. But if you monitor the score distribution and someone deploys a bug or a client changes something, immediately your score output will change and you can immediately have a look at it. So this real-time capability is quite nice and it's very simple to monitor. Here's an example in depth about what Google is using in their data validation pipelines, also a paper from 2019. So they compare a single field and they have a before and after time frame in white and in black. And what they do is they bucket the different variables into bins and compare what share of the probability density function is in each bucket. So it's really heuristic, but it works quite well. Another great idea to monitor is a quality heuristic, which is human understandable. I was once in a talk by Spotify, and they told the audience that they have a heuristic for their homepage, which is a personalized ranking. And the heuristic was that the most used box by a user, so let's say you're always clicking into the weekly discovery, or you're always clicking on great 80 pop songs, then your most used box should not be ranked very low in a personalized ranking. So this is a great heuristic. It doesn't cover everything, but if this heuristic goes down, then obviously this algorithm probably is suddenly experiencing a problem. For my case of personalized recommendations, I also had a very simple baseline, which was the share of successfully personalized responses with at least 4 articles. That was also a great indicator when we have problems or incidents. So you can think of rule of thumbs in your case, and these work really well. And then if you still have time and you're matured in your monitoring endeavors of a specific use case, or maybe the use case is really critical, you move even further back in the pipeline and you start monitoring inputs and calculated features. So you can compare the input and feature distribution over time. And also, obviously, which is very important, is to compare it between training and serving. Here I'm making an exception. That would be priority 1 for me, to do this at least once, since I've in 100% of the cases I brought anything live seen differences here. But let's just talk about the normal monitoring of input data that everyone is, let's say, buzzing about in the industry. I would still put this at priority 3 after you did at least the monitoring of the evaluation metrics and the outputs. It will help you for debugging, but it is not the first thing I would implement. Okay, so how do you practically implement this, and do you need any specific tooling for this? So I am in a Slack channel about practitioners of MLOps, and I did a small survey to understand if anyone is using these monitoring tools. There's a bunch of these monitoring tools available, and it seems like many people are looking at the tools, but don't have necessarily a custom framework in use. What does that mean? So I would generally say, if your company already has other backend services and has some backend services in use for monitoring and alerting, then you should really use the existing tooling that you have, for example, Prometheus, Grafana, a job scheduler, etc. And you don't need a new tool unless you already are very advanced and you really understand what your requirements are. So these are not relieving you of the need to think about what you actually need to monitor and really understand, as you can see from my examples, really understand what things mean. So they're not really plug and play, in my opinion. However, if you have a data science product from scratch, or you're very advanced and you already know what are your typical bugs that you encounter in production, then you can evaluate the full featured platform and you know how to get the best value out of them. So that has an advantage. You don't need a new tool. You can start immediately, and it's usually sufficient for, I would say, at least 80% of use cases. And the tooling is developing very fast, and I don't think many of them are very mature yet. Here's an example how to do metrics. So metrics, you can really push them to, for example, CloudWatch on AWS that is available. So you don't need to set up a stack or anything. So what you do is, or here's an example how you push to Prometheus, which is something that pulls different services and you can push metrics there. There's another possibility. This will just give you the general idea what you have to add to your code. So basically what you add to your code is something here is a histogram, and then anytime your model makes a prediction, you just say, observe prediction score. And then it stores it in this histogram, and you can either push it regularly or it gets pulled, and then you can evaluate and alert on it. Another option would be that you log your response to storage, for example, S3, and you run a script every 10 minutes to calculate these metrics, and that is written somewhere else, for example, in a database, and then you add alerting. That is a bit clunky in the beginning, but it's usually sufficient if you have 1-2 use cases, and then you start to understand what your problems are. And I would really not start in an over-engineered fashion. So this is a nice way to start. So takeaway, you should monitor the golden signals, and then you add machine learning monitoring on top. And you should prioritize, in my opinion, monitoring the output metrics because they have direct user impacts, like response monitoring and, if available, evaluation metrics in production. You also don't need a new tool. you can use the tools you already have, or use very simple tools like AWS CloudWatch, and you add a few metrics. Okay, so if you're keen on applying at my company, we're also hiring in Germany, in Berlin, and I invite you to join the Ops channel, which is a really nice channel to talk to other people working on machine learning in production. Okay, thank you, everybody. So let me see, how do I address the queue? Do I have to look myself, or is someone reading these out? I think I have to watch myself. Yes, so Srikant is asking, if we don't have the ground truth data, then you cannot monitor prediction. Yeah, that's right. I said you can only do this if you get the ground truth data. If you do not have this, I would, like I said, I would monitor the output distribution, which is a great proxy for if anything changed. I did not use a gold standard reference data set. What I suggested was an actual, you could also do that, but what I did is I actually take part of the live traffic just in case the behavior live changes, and I get, with a delayed 1 or 2 minutes delay, I get the ground truth actual label in my case. So I can calculate live precision without an example data set. Yes, if the feature distribution changes significantly, do you change your monitoring thresholds? Yes, that is a problem, because actually you detect that something changed, and it did change. That's why I always start with monitoring the outputs, because in many cases, the inputs can change, but the model is still equally sure. For example, the distribution between the classes, but the model is still equally sure and doing a good job in predicting. That's why monitoring features can definitely get you more alerts that something changed, but it's actually not actionable. You're not changing anything in the model. Maybe after a while you need to retrain, but more often than not, you're not actually doing anything after looking into this change. That's why I don't particularly would start with that. I find it more helpful to use the feature monitoring to understand what was the reason for the output change. So in this case, it's useful to have together, but not by itself, just to understand that some features changed, and then so what? Does it have any impact on your output if you have 70 features? And what's the direct lever on the output? Okay, I will share the Slack channel, yes. Okay, 1 second. Any more questions that I might have missed? Because it seems I have to scan the case of recommendations. Filter bubble effect because of recommendations. So there are some custom hacks from the domain. We call it inverse propensity weighing, where we reweigh the data set with the probability of being observed. So if you keep recommending the same things which is popular, it basically gets down-weighted in the evaluation metric, but that's a hack for recommendations. Interestingly enough, there are no fairness requirements in my area. Banks are very concerned about the risk they're taking on for obvious reasons, right? Banks cannot crash because everybody is defaulting, but there's no fairness score yet that says something like you cannot reject minority XYZ more than something else. That's not something that is covered by the authorities as far as I know. Great question by Amir. What if your model does not have output confidence score? That is no problem. Any output score is okay. So what you do is you collect it and then you plot it over time. random forest is a great example. It has, if the data does not, normally the prediction, let's say in a classification, will not fluctuate drastically for most business cases. So then you can observe the quantiles. Good question. Incoming sparse data. So I would really, Christian is asking, distribution shift with incoming sparse data. Well, like I said, I would focus on monitoring the outputs. And was your question how to detect? Maybe you can clarify your questions. Hit me up on LinkedIn if you want to talk in detail. I feel maybe I'm missing context for this question. Volatile targets. Yes, monitoring anything volatile is difficult. In many cases that I have had, actually the targets or the share of the targets, or at least the prediction score, which is also very nice. Let's say the targets are very volatile, but your certainty, or like, let's say the score, it's not really the certainty usually if it's not calibrated, is not volatile. We have a case in email routing where people on the weekend, or if something new is released, write about very different topics, not through the different days, but the model score that it's quite certain it's now this category or this category is not volatile. So the target, yes, but the score not. So that's a nice solution if that's the share of target is volatile. But if the whole thing is volatile, also the scores, then obviously you need to look into this example more deeply, see if you can do distribution comparisons, then it gets more tricky. I never had such a case. Like, thankfully, if you go, for example, to the score and not the category itself, the cases I've seen, which I hopefully can generalize, having seen quite a few, were not that highly volatile. If you were cramped for time and don't expect a data distribution shift in your production data, always have at least this ground truth pipeline or the output scores. It's not that much work to, just store it. If you're really sure you can go live without it, fingers crossed, but I would probably at least manually run it, like every day, like log it away, write a simple script, manually run it, and then a few days later automate it. That would be my advice. Sparse data and prediction. Do you mean the input data? Not quite sure what you mean. Okay, so let me see if I can find the Slack channel for you guys. Fraud prevention. Yes, I gave an example for fraud. So what we do is we just let a really small percentage through. So you think it's fraud. So what you do is maybe, depending on how much traffic you had, really small percentage or slightly bigger, you still let it through and observe if what you said, let's say you said this request is fraud, and then you eat the cost for the fraud, and you actually let it through to determine if it was fraud. That's what we did in e-commerce, to be sure that the model is not, you're rejecting everybody left and right, but the model is actually not correct. That's obviously not what you can do in bank fraud. So in bank fraud, what they have is they classify everything that looks like fraud as fraud, and then there are humans in the loop which look at every fraudulent transaction and determine if it really was fraud. So it depends on the domain a little bit what you can do. Yes, Slack channel, 1 second. Statistically, we wanted to not have too little that we can have accidentally false positives, but no need to be overly, overly analytical with that. You don't want to have it too low that you calculate the standard deviation of this, that it would be too low to detect anything, and you don't want it too high because then you can't save anything. And then it's like, I have not used XAI, explainable AI, in practice. I think it's a huge buzz in understanding and an important topic. In productionizing, I have not seen it yet hit the, in my experience, has not been requested. For monitoring with the customers, so I would monitor per model, definitely. And also per, I did something like in my last job, anything that can break independently. So for example, if you are being called on Chrome and, sorry, on Android, and you're being called on web and on iOS, you want to add that as a monitoring dimension so you can detect it. How did you convince managers? Okay, well, in my company, they were actually interested. So it means if it's not fraud, you can offer paying by invoice in Germany. So what domain do you have? So if you pay by invoice, more customers convert. So that's a better conversion rate. So it depends what the business case for fraud is. So to answer this generally, I would convince them with the business case. Why do you need to know how good the model is? And that should be connected to the business case. Do I recommend open source monitoring tools? No. The good news is that was the talk. The talk was about that. So I use Prometheus, but you can use different packages for general backend monitoring that you do not need a specific ML monitoring solution. So everybody asked me for tools, but this is really more about understanding what you want to monitor, and then you pick simple backend tools or whatever is available in your company, or you log it out and run a script, whatever you have available. There is no use this tool and your golden solution, but the good news is with the output monitoring and the ground truth monitoring, it's also quite simple, I think. Clicks on recommendation. No, I did not use that because actually that is very noisy and it ends with the customer and click rate is very low. So in the recommendation case, monitoring the outputs, where you can get for 100% of the traffic, the score, for example, 60% or 80% were from a personalized recommendations with 4 items. This was a much more sensitive heuristic than the click rate, because the click rate, it's technically difficult to get, like there are different front ends, there's the web, there's the app, and so on. It's not real time. It also, people have blockers and only a small percentage clicks. So if you have a cross sell and it's normally, let's say, 90% filled from this algorithm, and now it's 85% filled, you can see that easily. Whereas if you try to monitor a noisy click rate, you're never going to see a 10% decrease. So in this case, monitoring the outputs is much more useful. Although if you could get it, it's a lot of technical effort. The click rate would be, of course, the ground truth to see huge fuck-ups, but you wouldn't see like small decreases. 10% is already not that small, but you wouldn't see that in the click rate. So feeding back for retraining offline. We did not feed that back, so we're working with 98% accuracy in my case. So I know I have a small incorrectness on my training data, but that's good enough to train on. I would have no way of understanding the huge share I didn't run this live test set on, in which cases I made a small mistake. But what you can do is you have this test set, of course, and what I also do is I only evaluate my new algorithm iterations, although the training data is a little bit, like it has this 2% error rate. I evaluate it on the unbiased live test set. Log as much as possible. Yes, as much as possible. Yes, they're never happy. And sometimes they're overreaching also and don't understand. So what I do is, of course, what you also do in logging, you remove personal identifiable data. You don't put that in your logs. but you log everything else, like features and so on. That's often a compromise. They still have some way to go to find a good equilibrium between what customers also expect in terms of personalization and features, and what the legal people in Germany just want to forbid everything. Recording, yes, the recording will be shared. You guys have great questions. If I missed anything, because the chat is very long and it's hard for me to scan, maybe can you repeat your question? Image monitoring, yes, that's actually, I'm sorry about that part. That's sort of a blind spot for me because I have not worked with image prediction. However, the output monitoring still applies. Usually the input is an image and the output is a classification or something like that. So the general advice of output monitoring still applies. For input monitoring, I also would have to ask friends, Google, think about it. Sorry, no image background, but let me know if you have a classification or what kind of problem, what kind of machine learning setup you have, Rita. Any additional monitoring? Well, I used to have, when I was at Zalando, sort of an A/B test setup where I would have deploy one model and then the other model, and I would have these quality heuristics. Let's say 90% are served from the best algorithm with 4 articles in this stack, and then it's 75% on the second stack. So I would record that as a difference of -5 and roll out and gradually switch over. But that's quite, let's say, advanced monitoring. Most people don't need that. So you can just know, you monitor it at this point, you make an annotation in the graph, and you see if it, normally many of these heuristics are quite stable over time. So you don't need an A/B test while you deploy. It's helpful, but you don't need it. So if it's normally like here, and then you deploy, and then it's like here, that's also usually good to detect it. Like, we do that during training also. Like if we make a new model deployment, before we do that, and we have a newly trained model, we download the live model and we evaluate on test data, but that's not, I wouldn't call that monitoring. Monitoring is more what's live in production. What checks do you recommend before pushing to production? Similar techniques to prod monitoring. Well, what I do is I download the existing model from live, and I download recent this live test set that I have, and I evaluate both the live model and the new model on this test set and see if it improves, and only roll it out then. But in generally, yeah, it really depends a little bit if you need special checks during staging. I don't think so. In many cases, you do the checks that you do during training to see if you even release a model. These are good. And then, yeah, why bother too long with staging, in my opinion, and then just go to live. And if it's bad, I just roll back. I have not yet used SageMakers. I usually had in-house solutions. Input text. Yeah, very interesting. We had this NLP email classification, and the question is, should we monitor the input text? Because we actually knew that it would change. Sometimes people write about this problem, and then maybe a new app feature is released, and then people write mostly about another problem. And I asked my colleagues that, do you know, if you knew that the input text changed, would you do anything? And they basically said, well, that's nice to know, but we wouldn't change anything unless the model quality has an issue. And for this, we just look, like I said, as the score of the most likely category. So even if the categories substantially changes and the model is still quite certain, and then we have the delayed ground truth monitoring, they said it would create alerts, but they wouldn't really, need to look at it. So unless you have a case where you can ask yourself, if I knew that the input text changed, what would I do exactly to remedy the situation, and you don't have a concrete idea what you would do, then it's not an actionable alert. Any papers detect drift 2 months on the monthly trained model? So you're saying the model gets less correct over time. So I'm quite pragmatic with that. So I have ground truth monitoring, and I just retrain the model if it dips over a certain precision threshold. So I'm not seeing the need to approach this super scientifically if like rules of thumbs work well. Who should be responsible for monitoring? Oh, that is a huge problem. Like somehow no one feels responsible for monitoring. It's a bit difficult. Technical monitoring. Well, I personally am liking to work in the mindset where the colleagues who develop the model also try to understand how the customer experience is. And I'm also educating the DevOps engineers or the backend engineers on how the alerts work. With limited success, I have to say. They can debug and they will debug the technical metrics, but they're not willing to debug usually the data-related or model-related metrics or even look at them. So it's a bit of an open question who owns the quality, sadly, of a machine learning product, especially when you have to move on to new projects. And at some point you have a few products live and alerts come in, and it's a bit unclear who should look at them. So we at some point established a rotation of one of us, each one per week, being sort of on call, but only during office hours to look at metrics to make it a bit more fair, at least between the data scientists or ML engineers. Unsolved problem. Also, generally owning the data quality or the quality of the metric. Like the product also often doesn't feel like they own the quality of the service. Very dissimilar to if they had a normal backend service. I'm sort of evangelizing that everybody cares about the quality of the live products. Ground truth data. I think that would be a bit too big. Several different business and ML applications. I don't think I can be an expert on all of these. People with domain knowledge always have a better grasp on, how you could have a rule of thumb. But hopefully these general heuristics that I gave on output scores and so on should work for you. Feature importance. Yeah, I have a strong opinion on this. I think this is absolutely useless. And I can tell you why, because feature importance somehow is not measuring if the feature is really relevant for the underlying business problem. It's only relevant for telling you what the algorithm tells you that it uses. So it could be if you have two highly correlated features and the algorithm uses both, then they, for example, get used half of the time each because they are, let's say, identical. And this will not help any of you to understand how important this feature is, because there was just this identical feature, so it looks like they're both worth half. Just a simple example, and there are more examples where I found that the feature importance only tells me about how the algorithm works internally, but not really how the underlying problem works. So that's often super confusing for the stakeholder, and they can't deal with these. Basically, I think of them as more internal debugging tools. I know it's counter to popular frameworks, which they all use this and show it to the end stakeholder. I'm not fond of that. In case when a customer uploads their data and trains their own model on the dashboard. I don't understand. Maybe you can rephrase your questions. A cadence, is cadence like a repetition? How often? Well, this is real time, so this is continuously running. Michael was asking how often should this be done. So this is automated. This is running automatically all the time, and you get an alert when something is going wrong. So this is the most important part of that. You don't know, no one needs to run a manual job. And maybe, I don't know all the domains, caveat about feature importance. So maybe in some domains, certain feature importance metrics, might be helpful. I'm maybe a bit, strong on certain sentences, but I'm not saying always, just in my experience on my use cases, let's say. Proper ML monitoring right now with the S team. Occasional breakages. Monitoring oversights. Well, first of all, they're not adding ML monitoring at all, or it's not automated. And then what I would also say is good is to have not only this monitoring that I added, but qualitative monitoring. So I'm always collecting bad user experiences. Also, in addition to, let's say, the technical monitoring, do you introduce a bug? Is something going down? Which shows you subsets of the population that have a problem, or cases where your algorithmic design is not properly matching the expectation. So actually also like talking to colleagues in the company, looking at your own experiences, trying to get bad user experiences with screenshots and having like a proper postmortem to understand why the algorithm gave such a weird result. And I was trying to establish that with my product team once a week or bi-weekly to not only do this automated monitoring, but also have qualitative debugging of bad user experiences. Weighing the labels on output certainty. Well, it depends what your goal is. My goal was just to detect that something changed and possibly broke. Often there is no need to make this, I mean, certainly you can if you have a very specific cost function or scenario in mind where you care a lot more about one category than another, you can adapt it, of course, yeah. If you observe a fall in monitoring, what do you do? Well, it depends what the reason is that it fell. So first of all, let's say it fell. So what you first do is you try to understand what happened. So then you can document to understand what happened. So A, did you deploy something? Try rolling back, does it fix it? If yes, that was your deployment. Did the client deploy anything? You can talk to them, you can check the logs, did they deploy anything? If yes, that broke it. If not, it's probably something else. I mean, there's only limited amount of components. It could be the input data changed. In this case, you need to either manually dig into this, or maybe you already have input data monitoring, then you check if that changed and caused this problem. So there's n moving parts that can change. I don't think continual learning is usually the answer, because in my experience, a bug is the root cause, or the client changed something, and it's often a bug, not actually the data shifting. So I would just personally just increase the amount of retraining. We had one case in Zalando where we just trained every hour. That is still less complex than continuous learning. Okay, cool questions, everybody. I think we are over time now. Last questions. You're on fire, like so many good questions. You can also hit me up on LinkedIn, and I also freelance if anyone wants in depth, but I'm not pitching, that's just to mention. Or just talk to me on LinkedIn, I'm always interested. Automated training set up on the basis of a monitoring tool. In many cases, the training in the bank is still manual because we often need to adapt something and only need to do it every 2 months. In Zalando, obviously, that was automated because a lot changed and we were having it nightly. So it depends. The monitoring is fully independent of if the training is automated. Cool. Okay, thank you, everybody. See you.